All right, so this is the one that you have to set up your 30, 60, 90 triangles and your 45, 45, 90 triangles with the variables. So this is not the 1 root 3, 2. This is now, God bless you, give them values. So opposite the third, there's two triangles here. If I look at the left one first, this would be my A side. This would be my A root 3. This would be my 2A. So I have the value on the 2A side. I want to solve for A. A is going to be 9 over 2 or 4.5. You could use either one. Which means that's why 4.5 or 9 over 2. And then X would be that times square root 3. So 4.5 square root 3 or 9 over 2 square root 3. Again, either answer is fine. Then once you get that side, now you can look at the right triangle, the one on the right, which would be a 30, 60, 90 triangle again. This time, the side opposite the 30 degrees is on the bottom. So this is your A. This would be your A root 3, and this would be your 2A. So the side, God bless you, given for this one is 4.5 equals A root 3, or A root 3 equals 9 over 2. So if I had A root 3 equals 9 over 2, I'd have to divide both sides by root 3. This would be 9 over 2 times 1/3, 1 over root 3. 9 over 2 root 3, which gets rationalized to 9 root 3. This would be 2 times 3, which is 6, and then that gets reduced. Or it could have been 4.5, and then you would have to divide it by root 3. So that's your A, which would be here where the Z is. And then this is 2 times that, which is just 3 root 3. That's the W. So you have to use the triangle on the left to get to the triangle on the right. This is a great standardized test question. Standardized tests assume they give you, actually the SAT gives you in their little like reference box the 30, 60, 90 and the 45, 45, 90 triangles. The ACT doesn't give you anything, but the SAT does give you that. But then there's usually some sort of application like this one where it's not like straight up. You have to use the application of it. Yeah. 95. All right, so 61 says find the exact values of the 6 trig functions of each angle, rationalize the denominators when applicable. Okay, so there's 2 ways to do it. One is find a coterminal that's positive, and it might be the easiest way when it's something like this. So if I just add 360 to it, I get 60 degrees. So I'm looking for that angle, which would be first quadrant. The other way is negative 300 would come all the way back around. It would put it in the first quadrant. And then you're still finding the distance between that and the x-axis, which negative would be negative 360. So the distance between those two, God bless you, just absolute value both and subtract, and I'd get 60. So either way, you get 60 degrees, okay? So because it's a 60 degree, I would get 30, 60, 90. This would be 1, root 3, and 2. So then the sine of 60 degrees, so we're using the top angle this time, would be root 3 over 2. The cosine would be 1 over 2. The tangent would be root 3 over 1, so it stays root 3. The cosecant, I would flip this 2 over root 3, which would be 2 root 3 over 3. The secant would be 2, and the cotangent would be 1 over root 3, which is root 3 over 3. And then you want to check the signs. Because it's all in the first quadrant, everything stays positive. You're welcome. Other questions from the homework? Samuel? All right, so this is the one where we're given the cosine, right, and we want the angle. So because it's got a root 3 and a 2, I know I'm going to use the 30, 60, 90 triangle. This would be 1, root 3, and 2. So the one in which adjacent would be root 3 and hypotenuse would be 2 is 30 degrees, right? Adjacent to it is root 3. Hypotenuse is 2. So I know theta, the reference angle, is 30 degrees. Now I've got to look at my all students take calculus, and it's where cosine's positive. So that's going to happen in the first quadrant, and it's going to happen in the fourth quadrant. In the first quadrant, that 30 degrees is my reference angle, so 30 degrees is the first answer. And in the fourth quadrant, I would do 360 minus the 30 degrees, and I get 330. And that's where the second one comes from. Good? Yeah? Anyone else? Oh. All right, so now solving right triangles. So again, we're using the word SOHCAHTOA. This time you're going to get given a right triangle with all sorts of angle measurements, all sorts of side measurements, and you're going to be looking to solve that triangle. So SOHCAHTOA, again, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. We're going to label our triangle with whichever information that we're given. Capital letters are your angles, lowercase letters are your sides, and they are opposite them. So if this was A, B, C, then opposite A goes little a, opposite B goes little b, and opposite C goes little c. They're going to give you two of those things, either an angle and a side, or two angles and you're looking for a side, or two sides and you're going to end up looking for the angle. And you will set up from there SOHCAHTOA. Not two angles. They won't give you two angles. That's different. They will give you a side and an angle, or they will give you two sides. And then you're going to solve, when it says solve the triangle, it's all the missing sides and all the missing angles. So at the end, you should have A, capital A, lowercase, angle A, side A, angle B, side B. Angle C is usually the right angle, so you would always know that one. But then you would find side C. All right, so it says solve the right triangle. Round your answers to the nearest tenth. So A, this angle is 31.67 degrees. Side A is 35.9. And solve means find everything that's missing. So I am missing from there angle B. Angle C is marked as a right angle, so I know that one. I don't know side B, and I don't know side C. So I'm missing three things. Yep. Say, is it, oh, yeah, these will always be right triangles. Yep. Otherwise, you can't use SOHCAHTOA. Okay, so if I'm looking at this triangle, the first thing, if they give you an angle, I would say the first and easiest thing to do is find the other one. What's true about all the angles in a triangle? They have to add up to 180. So if one of them is a 90-degree angle, what's the relationship between the other two? They don't have to be 45, but they have to add to 90. So these are going to be complementary, okay? You can either do 180 minus 90 minus 31.67, or you could just do 90 minus 31.67 because of the 90-degree angle. So you get to choose there. So 90 minus 31.67 is 58.3, and it says to round to the nearest tenth, so I'm going to keep it, it's 3.3. I'm going to keep it as 0.3. Okay, now I need the side lengths. So I'm going to use the angle that they gave me to start with. I'm going to use this one for the sole purpose that, one, it's 2 decimal places, so it's a little bit more accurate. 2, I know that's right because that was given to me. If by chance you make a mistake on finding B and you use B in what's to follow, you're going to get every answer wrong, okay? So stick with what they gave you. So they gave me angle A and they gave me side A. In respect to angle A, where is 35.9? Opposite, right? And if I want to find B first, let's say side B, what in respect to that 31.67, what relationship is that? Adjacent. So which of my trig functions is opposite and adjacent? Tangent. So I'm going to say the tangent of 31.67 equals the opposite side, which is 35.9, over the adjacent side, which is the B. Now I'm going to solve for B. So I'm going to show you a shortcut in a minute, but if I just wanted to solve this equation, I would multiply both sides by B. I would get B times the tan of 31.67 equals 35.9, because these would cancel. And then I would divide both sides by the tangent of 31, God bless you, 0.67. So So B equals, and then I type that in the calculator. This is where you got to be really careful for those of you that have graphing utilities. If I've had you reset them, right, for your test, it puts it into radians. So you want to hit the mode button. The mode button is on the top, right next to your second button. There's a mode button there. You want to hit that button, and you want to make sure the third line, the word degree, is highlighted. So it needs to be in degrees. So then I would do 35.9 divided by the tangent of 31.67, and I get 58.19, which we're going to round to 58.2. Wait, that doesn't make, that's my angle. Did I type it in the wrong thing? 35.9 divided by the tangent of 31.67. Oh, that's right. That's funny. Are you in degrees? Okay, so now I need to find side C. I actually have options here technically. I could do the Pythagorean theorem. I could use side B with C. But again, the most accurate thing is to go back to what you were given. So the information I was given was angle A and side A. And if I pair it with side C, the 35.9 is still opposite the angle. C is now what? Hypotenuse. So what's opposite in hypotenuse? Sine. So I do the sine of 31.67 equals opposite, which is 35.9, over hypotenuse. Now here's the shortcut for these kinds of equations. If the variable is in the denominator, just take the numerator of that and divide it by the other side. So C equals 35.9 over sine of 31.67. It just saves you a couple steps. 35.9 divided by the sine of 31.67. And C equals 68.37. So we're going to round that to 68.4. And that's the last piece of information we needed. All right. Set it up. So solve the right triangle, and again, round answers to the nearest tenth. So B is angle B, 47.8 degrees. Side C is 89.6. So we are missing angle A, we are missing side A, and we are missing side B. What's the easiest thing to find? Angle A. This would be 90 minus 47.8. And I get 42.2 degrees. Then I want to find side A. I use the information I was already given. So angle B in respect to side A, what's that relationship? Adjacent, okay? And then C is what? Hypotenuse. So what's adjacent and hypotenuse? Cosine. Cosine of 47.8 is going to equal A over 89.6. Now, if the value's in the bottom and the variable's in the top, all we have to do is multiply 89.6. So 89.6 times the cosine of 47.8. And I get A equals 60.18, so we're going to round this to 60.2. And then I need to find B. So again, I'm going to go back to the original information I was given. In respect to the 47.8, B is where? Opposite. 89.6 is? Hypotenuse. What's opposite in hypotenuse? Sine. So sine of 47.8 equals B over 89.6. Multiply both sides by 89.6. And I get B equals 89.6 times the sine of 47.8. Questions? All right, so for 3, you were given angle A, 61 degrees, and then side B, 39.2 degrees. So to find angle B, we're going to subtract 61 from 90, and you should get 29 degrees. And then based on the original information I was given, if I want to find A, I'm going to use angle A, and side B, which would be opposite and adjacent, so that's tangent. Tangent of 61 would equal A over 39.2, and then I just multiply both sides by 39.2. And I get A equals 70.7. Then if I want to find C, I'm going to use angle A, side B, and C. So this is now adjacent and hypotenuse, which would be cosine. Cosine of 61 would be 39.2 over C. Now the number's in the top, so I divide this by the other side. 39.2 divided by the cosine of 61. And I get C is 80.85, so I'm going to round that to 80.6. Raise your hand if you got it right. Okay, good. Second one, now you're given B, so 90 minus angle B, which is 46, is 44 degrees. And then I want to stick with what I'm originally given. So angle B, if I want to find A, I am given the hypotenuse. A would be adjacent. Cosine 46 would equal A over 29.7. Multiply both sides. 29.7 cosine 46. And I get A equals 20.6. And then B, opposite and hypotenuse, this time that's sine. Sine of 46 equals B over 29.7. And we multiply. 29.7 divided by sine of 46. And I'm sorry, 29.7 times the sine of 46. And I get 21.36, so 21.4 when it's rounded. Yeah. I mean, these should be pretty exact. Yeah. I don't know how many points, but yeah. Oh, yeah. Sorry, this should 89.8. Where did I even go? Oh, I did the 5. Bumped the 5 up. That should be 8.5 would round up to 9. Is that what your thing too was? Yeah, okay. All right, so now look at the next set of examples. This says solve the right triangle, same set of directions, except it tells you C is the right angle. So again, when you draw it, you know to label C is the right angle. Round the answers to the nearest tenth. So if I were to label A, B, C, C is the right angle. This time it gives me side A is 958 and side B is 489. So what's different now than before? I don't have any angles besides the 90 degrees, but I'm given 2 sides. So pick an angle to solve for first. I know I'm going to have to do angle A, I'm going to have to do angle B, and I'm going to have to do side C. So let's pick alphabetical order. Let's go with A, okay? If angle A is here, and the 2 sides I'm given are here and here, what's the relationship to A of those 2 sides? It would be opposite and adjacent, which is tangent. So if I set up a statement, I could say tangent of A equals 958 over 489. So I don't know my angle, but I know the 2 sides. When I know the ratio and I'm looking for the angle, that's when I use the -1 buttons on your calculator. So if I'm given the actual value of the trig function, which is what the 958 over 489 is, and I'm missing the angle, then I do tan -1 of that exact fraction. Don't do anything with that fraction. So second tangent, that's where tan -1 is, 958 divided by 489, and I get that angle A is 62.95. The 5's going to bump up the 9, which is going to bump up the 2. So it's 63 degrees. Now I've got this one. How can I find B? You can do the same thing, but flip it. I can say the tangent of B would be 489 over 958, and then I would tan -1 that. Second tan 489 divided by 958. And I get B is 27.0. Now, how else could I have found angle B if I knew angle A? Good. I could just subtract the 63 from the 90. So you can do either one. Sometimes you might be a tenth off, but if you don't, on that one it wouldn't matter. You could do either one. It's safer to do the way we did it because that's based on the information that was given, not what we found. But it's obviously easier to do the 90 minus. Why would I put what? Because this time you have the trig function and you're missing the angle.
So when you want to find the angle,
Yep. All right, so set up 6. Oh, and then I need side C. In order to get side C, you have two options. Pythagorean theorem, because I know two sides, and they were both given to me. Or I can set up one of the trig functions with one of the angles we just found. The actual most accurate would be Pythagorean theorem because those are the measurements that were given to me. So I can do 489 squared plus 958 squared equals C squared. So I'm going to square root, and you can do it all in one step. Square root 489 squared plus 958 squared. And I get C equals 1075.58, so it would be 0.6. Now, it's a big number, but it makes sense. It's opposite the biggest angle, so it should be the biggest number. And the other numbers, I mean, one was 958, so they were all big numbers to start with. Okay, now we're going to set up 6. So C is still the right angle. A and B, it doesn't matter where you put them, just label. Opposite the A would be 26.5. Opposite the C is 39.7. So this time I'm missing angle A, angle B, and side B. So if I want to find angle A, 26.5 is where in respect to angle A? Opposite, 39.7 is hypotenuse. So this time I'm using sine. Sine of A would equal 26.5 over 39.7. I'm still looking for the angle and I'm given the side length, so I'm going to do sine -1 of that ratio. So second sine 26.5 divided by 39.7. And I get angle A equals 41.9. So now I've got this one. If I want to find B, I can either subtract that from 90 or I can use B and cosine. Cosine of B would equal 26.5 over 39.7, and then I cosine -1. 26.5 divided by 39.7, and angle B is 48.1. Add those two, they should give you 90. And then the last thing I need to find is side B, and I'm going to use the Pythagorean theorem. 26.5 squared plus B squared would equal 39.7 squared. So B squared is going to equal 39.7 squared minus 26.5 squared. And then the last thing I'm going to do is square root that whole thing. So the square root of 39.7 squared minus 26.5 squared. And B equals 29.6. If you did, well, which ones did you pick?
I did sine of B.
You did sine of B. So sine of 48.1 equals B over 39.7, and then multiply, right? So you might, depending on how it rounds, you might be like 1/10 off, but as long as you've got the work to show what you did, it's fine. It's to give you credit. Yeah, because you get this. No, you get 29.5 on that. So depending on how you set it up, you could be just like off. Yeah, as long as you show this. So like the thing with work on these, I would say, is at least give me your initial setup. Your calculator does the rest of it, but at least give me your initial setup so that I know where you went wrong if you did. Good on that. Okay, the rest is completely calculator work. So there are two different types, and you'll see them when you look at the slides. This is the first type, and notice what's happening here. It's saying that the secant of 31.67, it's giving you the degrees. So if it had said, for example, let's say it said sine of 31.67 degrees, I would literally just hit sine of 31.67 degrees, and I would get 0.5250, so on and so forth. This is a reciprocal function. So the secant is the same thing as what? 1 over cosine. So I do 1 over cosine of 31.67 degrees. 1 divided by cosine 31.67 degrees. And I get 1.17. Because it says to round to 3 decimal places. So that would be the secant of 31.67. For 8, I get the cosecant of 131 degrees, 45 minutes, and 25 seconds. So I would do 1 over the sine of 131 degrees, 45 minutes, 25 seconds, which you can either convert and then use that number, or you can type it in exactly like this. So 1 divided by its sine, you do 131 second. Apps to the angle menu, grab your degree symbol. 45 second apps, grab your single tick mark, and 25 alpha plus to get the double tick mark. Okay, and then the last one, cotangent. So this would be 1 divided by the tangent of 81.8, which is 0.144. So if we were finding sine or cosine, the numbers should never be bigger than 1. But the tangent and the rules are the opposite, right? For secant and cosecant. And cotangent can be either. Questions on those? So notice that I'm given the actual angle this time. Yeah.
How do you find the double tick mark on the calculator?
It's alpha plus. So the green button and then your plus symbol all the way in the bottom right.
Okay.
You see it?
Yeah.
Yeah, okay. Now the directions have changed and the type of problem has changed. So now it says find the value of theta. So what does that mean? What are we looking for? An angle. If we're looking for an angle, which buttons do we use? All the negative ones. So sine -1, cosine -1, tan -1. So as soon as you look at the problem, realize what you're looking for, and then that determines which buttons you're going to hit. So if it gives you the angle and you're looking for the trig function, you use the regular ones. Those were like the ones we just did. If you're given the trig function and you're looking for theta or the angle, that's when you hit the negative ones. So this says find a value of theta on the interval of 0 to 360 that satisfies this statement. Round your answers to 3 decimal places. So think about it yesterday when we did those ending ones, that there were multiple answers if we went from 0 to 360. The same thing's going to happen here. So if I say 10, if I say, oh, all right, so it says the sine of theta equals 0.6456, 0.67456. So to get the angle, I'm going to do sine -1 of 0.67456. I'm going to type that whole thing in the calculator. 0.67456. And I get that theta equals 42. It says to 3 decimal places, so I'm going to keep all 3. 42.419, so bumps. 42.420 would be the angle. So this one gets a degree symbol. Yep.
Why would it just keep it 41?
It said to keep 3 decimal places this time. Is that what you mean?
No, but this already.
Because the 9 is here.
Oh.
So that bumped that. Sorry, I didn't say that. But yes, the 4th one was a 9. So now think about it. How many places are there on my 0 to 360 in which sine is positive? First quadrant and second quadrant. So I have the first quadrant measurement. That's my 42.42. I don't need the 0, but if I did, it would be there. degrees. That's the first angle. And then if that's a reference angle, I need to find the angle that would happen in the second quadrant. So I do 180 minus 42.42. And I get 137.58. So there are two answers here.
So since there's a positive for the number,
I'm doing where it's positive.
okay.
Yep. If it was negative, I'd pick the bottom two quadrants.
Is it gonna be a plus or minus one?
No. So the good news is these are easy to check. If I actually do sine of 42.42, I get 0.67456. All right, so I can check both of these. Like I did the sine of 42.42 and then the sine of 137.58, and they both give me 0.67456 and so on and so forth. So these are easy to check, okay? So now look at 11. It says tangent of theta is 1.45, so I'm going to do tan negative 1 of 1.45. Second, tangent 1.45. And I get theta equals 55.4077, so I'm going to round it to 408. Now, this is a positive tangent. Where is tangent positive? First and third. So the first means this is one of my answers. I keep that one. And the third would be, what do I do? 180 plus 55.408. Good. Not one, yeah, plus 55. I can't read my own writing. 55.408. And that's 235.408. And again, we could tangent both of those to check our answer. Yep.
Which one should be when I check?
You would do tangent of 55.408 and see that it gives us the 1.45. And then I would do tangent of 235.408 and see that it gives me the 1.45. Okay, questions on those? Because it gets a little trickier after this. Now, okay. Now you're in your reciprocal functions, right? So it is no longer 1 over tan negative 1 because this side is what is 1 over tangent. So if I were to rewrite it, it would look like this, right? In order to get them to be the same, we do tangent negative 1 of 1 over 1.7893. So I don't do 1 over. When I do it before, when I do, let's say I did cotangent of, 35 degrees. This is 1 over the tangent of 35. So the 1 goes first, 1 over the whole thing. Now, if I'm looking for the angle, the 1 does not come first. The inverse tangent comes first, and then I do 1 over 1.27893, like that. So that's the difference between if I'm looking for the angle or if I'm looking for the side. When I'm looking for the trig function. The trig function, I do 1 first, 1 divided by, and then the reciprocal function. When we're looking for the angle, we have to do the reciprocal function first and then 1 over it. So second, tan negative 1, 1 divided by 1.27893. And I'd get theta equals 38.022 degrees. It's positive in what two quadrants? If it's cotangent, it takes on the same, right, as tangent. So where did we say tangent was positive? First and third. So I keep this one for my first. And then for the third, I would do 180 plus 38.022. And so the second angle is 218.022. Yep. Oh, all right, he's probably in the wrong mode. Are you in the wrong mode? No. Okay, so here's the last one and the most confusing one because now it's negative. So it's a cotangent, which means it's the it's the inverse tangent of 1 over, right? But it's also negative. So for me, the easiest way to do the negatives, and this isn't the only way, but for me, the easiest way to do the negatives is to figure out the reference angle based on the positive value. So I actually would go through and I would say that the tan negative 1 of 1 over, equals of 1 over 1.27893, which we already did, and I would get my reference angle is 38.022. But that would be where it's positive and my value here is negative. So I go to my all students take calculus and I say, where would cotangent and tangent be negative? Second quadrant and fourth quadrant. So now this is not one of my answers. 38.022 is not one of the answers. That would be where it's positive. I have to go to where it would be negative. So I'm going to find the angle in the second quadrant and in the fourth quadrant. So in the second, we do 180 minus that reference angle. And in the fourth quadrant, we do 360 minus that angle. So 180 minus 38.022, which is 141.978, and 360 minus 38.022, which is 321.978. So those would be the two angles. That would be my answers. And we can check them by doing 1 divided by the tangent of 141.978, and I get negative 1.278929, which would bump up. And then I can do 1 divided by the tangent of 321.978, and I get the same answer. So I would say people get the most confused on when to do the 1 over and when to do the trig function. And then the 1 over trig function of an angle is when you're given an angle. So the first ones where you're given the angles, you do 1 divided by first. And then when it's these, when you're looking for the angle, you're going to do the inverse trig function first and then do the reciprocal of the actual value that they give you. So 1 over that. Yeah. Say again? So the difference would be that, like this question or cotangent of 141.978 degrees. So if I'm not looking for the angle, if I'm given the angle, this is 1 over tan of 141.978. If I'm looking for the angle, I do the inverse first, so tan negative 1, and I put 1 over the value that's given to me. So that's the difference there. Questions? All right, so